Okay, good morning. Today I'm going to quickly take you through another percent proportion problem, one that you have to take one extra step in that I would just want to go over with you guys. So let's say I'm going out to dinner and I want to leave the server a 20% tip, and that tip ends up being $30. What now was the original dinner bill to amount to a 20% $30 tip? Okay, well, let's break it down like we normally do. Let's identify the part, the whole, and the percent. Well, the part is going to be that $30. That's the part of the whole dinner bill. So we're going to those two are connected. This is the smaller of the two. So 30 is going to be my part. As I just mentioned, the whole is going to be the total amount that the dinner bill came out to be. We don't know that yet. So we're going to leave that as X. And our percent, what we're going to tip our server is 20%. Since we're using the proportion method, we can leave it in percentage form as opposed to decimal. So that's going to be 20. So let's set up our proportion. Part over whole equals percent over 100. Remember, this is the standard formula that we're going to use this over and over again. So make sure that you guys are memorizing this. Part over whole equals percent over 100. We've identified all of our components here. Let's plug them in. Our part is 30. Our whole is X. Our percent is 20. And that's over 100. Great. Now we just need to solve for X. We're always looking for a relationship between our known numbers. So I'm looking up here and seeing, hey, is there a relationship between 30 and 20? And there's not a nice relationship. So when there's no relationship, we need to solve for X. We need to isolate this X down here. Again, when there's no relationship, we need to solve for X by isolating it. Now, it's really hard to solve for X when it's in the denominator. So our first step in solving for X is we need to flip both of our fractions. What we're going to do, we're going to treat this like a fraction and that like a fraction, and we're going to find the reciprocal of each one. So what I'm going to do is flip this fraction around so that my X ends up in my numerator, because that's a lot easier to manipulate and isolate. So my next step down here, I'm going to flip the first fraction. The numerator becomes the denominator and the denominator becomes the numerator. But if I do that to the left side of my equation, I have to do that to the right side as well. So that's going to get flipped. Okay, now we're ready to solve for X. X is being divided by 30. So I need to multiply by 30, doing the opposite operation. And I'm going to do that to the right side as well. My 30s are going to drop out. Now let's clean this up. So I've got X all by itself. This becomes a multiplying fractions problem. So I'm just going to multiply my numerators together, multiply my denominators together. 100 times 30. Well, 100, that's a nice number to deal with. All I need to do is add 2 zeros to this 30. So this becomes a 3,000. So 30 times 100, or 100 times 30 is 3,000. And that's going to be over 20 times 1. That's 20. So now I just need to do some computing. We can use our calculator for this. I'm going to do 3,000 divided by 20. and I'm going to get 150. And what was that X? Well, let's go back to our original setup. That X was the whole, or in this case, our dinner bill. So our dinner bill was $150. And that's it. I just wanted to show you guys what to do when you come into a proportion where the X, the variable, is in the denominator. I wanted to show that you needed to flip that. So that's that. Thanks for listening.